Hey everybody. I just got my first look at Cisco Packet Tracer Virtual Environment. It's pretty cool. I've been working in GNS3 and EVENG, EVENG, that's Emulated Virtual Environment Next Generation. I've been working in those for years. Packet Tracer, just got my first look at it. It's pretty cool. It's got some nice things that I would like to show you. To start with, down here at the bottom, there's routers, switches, hubs, wireless devices. You can see it changes the selection over here. Firewalls, some 5500s, and WAN clouds. Here's the type of connections on this lightning bolt. Shows the different types of connectors that you can make between devices. So let's throw a couple routers in here. Click on routers. I'm going to grab a couple 2900s. Throw a couple 2900s up here. It names them router 0 and router 1 to keep them unique. Whenever you drag them up there, they power on automatically. And you can see that by clicking on one of them. Here's router 0. You can see it's router 0 right there. Click on router 1. You can see that that's router 1. It's labeled right there. Zoom in. You can actually see what a router like this looks like physically, as if you were holding it in your hands. This is a difference between EVENG is they don't have cute little pictures like this. This is really nice. If you can't get your hands on expensive routers, Cisco does a great job of showing you what they look like. Here's a power button. You can actually flick this, it'll turn the green light off. Here, I'll show you real quick. If you go to command line interface, this is what it looks like if you were to plug in a console cable. The router has just booted up. It's in its system configuration dialog mode. It asks you, do you want to go through the dialog? I always say no to this. If you were to say yes, it asks you a series of questions, menu-driven or question-driven configuration. I don't ever do this. Whenever I set up a router, I set it up from scratch on my own. You're going to need to be comfortable with how to do that anyway, so you might as well get used to it. All right, so this is router 0, this is router 1. Go to CLI, you see that they booted up. So what I wanted to show you was, go back over to physical. If you hit this power button, it's now gray, okay? Go back over to CLI, device must be powered on. So the software emulates that you actually turned it off. It's pretty cool. Click it on, go back to CLI real fast, and you actually see the boot up sequence. All right, so it's actually decompressing the image that it as it would if it was a real router, and you're back to the menu-driven dialog again. That's because you didn't save your change from before. Now let's talk about saving your changes real quick. First of all, you are show privilege. You're in privilege level 1. This is called user exec. Type enable. Now you are in privilege level 15. It's the utmost of privilege levels. You can actually go to configuration mode in enable mode, privilege level 15. I just hit Control Z to get out of configuration mode. That's one way to get out. Here's another way to get out. Exit. All right, 2 ways to get out of config mode. The difference, I'll show you real quick. If you went into an interface, sub mode, if you type exit, it only drops you back 1 level. If you hit Control Z, it takes you out of config mode and out of all the levels of config mode. All right, so what I've already demonstrated here is config mode is a global configuration mode of the router. Just let me try to somehow put that to a picture real quick. If this was the configuration mode, if this was the way you configure the router on the whole, configuration that can apply to the entire router globally, that would represent that. So this is conf t, config t. If you want to configure interfaces, you then type int. After you type that, you go into global config mode. If you want to go into the interface, you type int, I'm just abbreviating, interface, and then the number of the interface. Then it drops you into that sub mode, okay? If you want to configure a routing process, like OSPF or something like that, you first start at config mode, then you go into router OSPF, you give it a process ID, and then it drops you into router OSPF mode. Okay, you have to exit out of that to get back out of that. Then you have to exit out of config mode to get back out of that, to get back to the command line interface of privilege exec. All right, so just trying to show you that when you're configuring things, you drop deeper and deeper into certain config modes. Control Z, if you're in here, or if you're in there, Control Z drops you all the way back out to the command line. All right, and takes you out of config mode altogether. Okay, so let's get back over here and look at that. So what was I talking about? We were looking at how it powered up. Oh, and so the reason after I powered it off and powered it back on and it asked us for the dialog again was because I didn't save the config. So again, let me talk to you real quick about configuration files. Here's the router, the piece of hardware. That's the router itself, okay? There's a memory chip in here somewhere, and we're going to call it NV random access memory. Non-volatile random access memory. Non-volatile means it doesn't change. It doesn't change from one moment to the next on its. It holds itself across power cycles. If you power the router off, it retains whatever's in there because of a battery that keeps the chip powered. You can power the router off for a long time, and whatever's in that non-volatile RAM chip will still be there when you power the router back on. The main thing we need to be concerned with, the biggest thing, or the topic right now, is the startup configuration. I'll just call it startup config. The startup config is in non-volatile memory. It doesn't change, or it doesn't get lost when you power the router off. Now, when you power the router on, if there's a startup config inside of the non-volatile RAM chip, as the router's powering up, it first loads the iOS router software, then it takes the configuration, the startup configuration, hence startup, and it starts the router up using that configuration. That action puts this into a memory space called volatile. Oh gosh, what's up with this marker? Volatile memory. And this configuration is now known as the running configuration. All right? When you go into config T, after the router's booted up, this happens as it's booting up. After the router's booted up, you as an engineer, administrator, go into config T. When you're making changes to the router and you're configuring it, you're actually configuring the running config. So let's say you turn up an interface. You put an IP address on it. You turn up a routing protocol. You make static routes. Whatever you do, you have changed this, and it changes. Let me add, the behavior of the router while it's powered up is in accordance with the running configuration. So if you make a change to running config, you're changing the way the router behaves immediately. Okay, as soon as you hit enter on that command, you have changed the behavior of the router. Now, after you've done that, you've made your changes and all that, if you don't save the running config back to NVRAM, if the router powers off, this is volatile. It goes away as soon as you power the router off. Okay, so if it lost power catastrophically, if you turned it off, flipped the power switch on it, whatever, somebody tripped on a cable and yanked it out of the power socket, if you made critical changes or any change to the running config and you didn't save the configuration and it got powered off, when the router boots back up, it's going to boot back up with the old version of the startup configuration. Whatever version was last saved. In other words, if you never saved it, it's booting up with nothing, and you're going to go right back to the menu-driven initial configuration dialog. All right? So you better know that. Let's show you how to make these changes. So let's get back over here, or let's show you how to save these changes, I should say. This is router 0, config T. The way you change the name of a router, let's name these routers. By default, a router prompt just says router. But if you change the name of it, that's actually where it gets changed. So let's call this router 0. Do you see what just changed? Automatically the prompt changes. So the name has changed. Now, show startup. You see no startup config. The old school way of saving the running configuration to startup is the command write. Boom. Hit the up arrow, show startup. Look at that. You now have a startup configuration, particularly with the change, hostname router 0. It's there in the startup configuration. All right. So that's the old school way to save the running config to startup config. The newer way of doing it is copy running config to startup config. And it even gives you a little message. Hey, we're gonna write to a destination file called startup config. By the way, dir shows you the file system, dir all. Can we see /all? Wow. Okay. Maybe we can't. Oh, here we go. dir question mark. NVRAM. Look at that. There's our startup configuration file. Hey, let's do this. Let me tell you how to erase the startup configuration. By the way, let me look me in the eyes. If you ever erase the startup configuration and you didn't intend to, and that router gets rebooted, you know it's going to happen. You're going to have the router's going to boot back up with no configuration. You're going to have a major network outage depending on where this router is positioned in the network. Small outage or major outage, whatever. And so I'm going to show you how to erase the config, but use it with caution. Obviously, in a lab environment, you're probably doing this all the time. This is how you factory default a router. You bring it back to its default configuration. Very useful in a lab environment when you're making changes all the time and you're trying to evaluate things. You're going to be factory defaulting it all the time. In a production environment, I'm just cautioning you. Be careful about erasing the startup config and then walking away from it. If it gets rebooted, there's going to be a problem. If you erase the startup config and then you write the running config back to startup immediately, you're okay. But I would tread lightly there. All right. So let's look back over here. We know we've saved a startup config. We see it. Here's how you erase the startup config. The old school way is write erase. Look at this, erasing the NVRAM file system. When you hit enter, you get a NV block init message, initialize the geometry of NVRAM whenever you erase the startup config. Let's do dir NVRAM now. Look at that, nothing there. There's no file in NVRAM anymore. All right, so that's here. Let's save running to startup. Now we have a file again. Here's the new way of doing it. Erase startup. No file there again. Copy run to star is a newer way of doing it. So now we're good to go. Okay, let's name this router host name router 1. Let's save the config. All right, and you know what? Let's get back to Packet Tracer. You want to make a connection? I love this. You can make on-the-fly connections when the routers are booted up. It asks you what interface do you want to use. G00 over here. It asks you where you want to land that connection. G00, and you've made a connection. Here's how you see the interfaces on a router. Show IP interface brief. Okay, so you see interface. You see the IP address has no assigned address. You see that it is administratively down. Okay, this is how you shut down a port. Not that command. It's actually with the command shutdown. So let's look at that. Show run, and let's begin our output. And I'm gonna first show you something. Show running configuration is how you look at the running configuration. All right, there's the whole running configuration. If you don't want to look at that whole thing, you can pipe it to begin at something. Let's begin at 00. That's going to begin at the interface G00. This command shutdown is why it says administratively down right now. Let's bring that interface. What you need to know is with Cisco commands, to disable a Cisco command, usually you put the word no in front of it. So config T interface G00 no shutdown. Look at that. It tells us the interface just changed state to up. Let's look at that. Show IP interface brief. Yes, it is in fact up. Protocol is still down, which means it's not sensing a link to the other side, indicated by these two red triangles. I love this about Packet Tracer. It actually shows you if it's detected a link or not. Let's go over here to the other router. Let's bring up the other side of this connection. No shut. Now look at that. We got a message on both of them immediately that the line protocol has now changed state to up. So protocol is more about the physical link and seeing the electrical signal from the other side. We know this isn't a literal electrical connection. This is a software virtual environment, okay? But Cisco has done a great job of emulating these things in software for us so that we can evaluate router configurations and stuff like that. So here we go. We've got up, 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 up. Just to show you real quick the way that you give an IP address to an interface. IP address is how you configure an IP address on an interface. Let's give it 10.10.10.1 on this side. We'll give it a /30 mask. Look at some of my subnet videos and we get into maskings and subnets and things. I'll probably elaborate on it a bit more later. But anyway, at this point, while we are about to configure the other side, let's ping it while we're doing it. Before I hit enter, let's get back over here, start that up again, hit enter, and let's watch that ping. There we go. It just started working. All right, so that's how you configure the basics of a router, just the host name, an IP address, bring some interfaces up with no shut. I do want to mention something else quickly, that Packet Tracer is not a full-blown, it doesn't appear to be a full-blown iOS image. EVE-NG, yes, you have to have actual router image files loaded into EVE-NG. When you boot up a virtual router in EVE-NG, you are booting up the actual router software file that you would use on a production hardware router. Okay, I see that this is not true. It doesn't appear to be true with Packet Tracer. The reason I'm saying that is show run. You should be able to show run interface, and you can't. The command doesn't exist. You should be able to show inventory. Command doesn't exist. So the fact that some of these commands don't exist lead me to believe that it's not a full-blown router image. I think it's emulating a certain version. If you go to show version and pipe include iOS, you can see that it's emulating this version of iOS software for this platform, 2900, okay? So just wanted to mention that. Now, in all virtual environments, GNS3, EVE-NG, Packet Tracer, it's still a software environment. You're not getting the actual hardware performance, obviously, and even the behaviors. There are some things that are quirky about software environments that would not be true, and you would not experience those quirks in a hardware environment. You still have bugs in a hardware environment, but there's even more strange things in a virtual server or PC emulator that is emulating the router, okay? I'll even add that there's some layer 2 bridging things that you can't do in some of these virtual environments. I think you can do some very, very nice bridging in Packet Tracer, but anyway, there's some things, suffice it to say that you don't have the actual router ASICs and all the behaviors of hardware in a software environment, all right? So this was fun. We got a good intro to Packet Tracer, got a good first look at it, introduced some basics of iOS configuration and router startup and some of the things you should be concerned with. So I hope it was helpful, and I look forward to the next time.